Okay, I wanted to go over these 4 special problems at the end of your special right triangles notes with you. If you look at the key and that's what you got on them, or you want to try them and see if you got that, then you don't have to watch anything else because you understood them. But if you need to look at them a little bit more carefully, here we go. Number 1, I drew this picture, but the key information is actually up here in the problem. The circumference of circle J is 14 pi. Okay, so the circumference of a circle is formula 2 pi r. If we know that that's equal to 14 pi, then I can find the radius. Divide 2 pi out of both sides. The pi's cancel. These all cancel. Pi's cancel. 14 divided by 2 is 7. So in this picture up here, the radius is 7. So I've got JK is 7. And JL is 7, and that makes it an isosceles right triangle. I forgot this little thing that tells me it's a right angle. So it's definitely an isosceles right triangle, and that means it's a 45, 45, 90, which means you take the leg and you multiply it times square root of 2, and that's how we know that x is 7 root 2. Okay? It'd be nice if they were all that easy, but they're not. Gets a little harder here. On number 2, we have a triangle ABC. Let's see, it's a right triangle. And then D is right here. And we have a semicircle. And the semicircle has AC as its diameter. Not too bad. Not perfect, but not too bad. So it says the area of semicircle D is 18 pi. Area of a circle is pi r squared. But I'm not going to set that equal to 18 pi because that's the whole circle. Semicircle would be that divided by 2. So that divided by 2 is equal to 18 pi. So now I get to solve this. First thing I would probably do is multiply both sides by 2. That gives me pi r squared equals 36 pi. The pi's are just going to cancel because they're going to divide out of both sides, so I might as well just get rid of them. R squared equals 36, that means my radius is 6. Okay, so if the radius of that circle is 6, that means that this is 6 and this is 6. So that whole hypotenuse of the right triangle is 12. And this angle right here is 30, so this is a 30, 60, 90. And so I have the hypotenuse of a 30, 60, 90. So that's what I'm looking at now. So I've got, let me just draw just the triangle. 12, 30, 60, 90. So the short leg over here, if the hypotenuse is 12, excuse me, you can't see it. If the hypotenuse is 12, 12 divided by 2 gives me the short leg, which is 6. And short leg times square root of 3 gives me the long leg. So it's 6 root 3. Now this is asking me for the perimeter of triangle ABC. So I actually did, on the key, actually I just realized I did the perimeter of the whole figure is what I thought they were asking. But now that I read it a little more closely, it's the perimeter of triangle ABC. So the perimeter of triangle ABC, we can just look at this picture because that's ABC. Here's A, here's B, here's C. So 6 plus 12 plus 6 root 3. Well, we talked about how adding and subtracting is all about like terms. These are like terms. This is not. So I'm going to put those together, 18 plus 6 root 3. And that is actually the correct answer for number 2. It's not the whole thing. It's just the area of the, the perimeter of the triangle. So 18 plus 6 root 3. Sorry about that. Number 3, find the perimeter of quadrilateral WXYZ. So this one is asking for the perimeter of the whole thing, which is what I was thinking the last time. Now I can think that. So WXYZ, and it tells me that from Z to Y is 43. And X to Y is 18 root 2. It shows me that this is actually a 45, 45, 90 right here. Okay, so this is the hypotenuse of a 45, 45, 90. If you want the leg of a 45, 45, 90 and you have the hypotenuse, you divide it by square root of 2. So 18 root 2 divided by square root of 2 will give me 18. So that's just from here to here. The reason that really matters is because that's also this side, which means this is 18. Then let's see, across the top, we have, well, it also matters because 43 minus 18 tells me how far it is from W to X. So 43 minus 18 is 25, so it's 25 units from W to X. Now I can find the perimeter by adding up this, plus this, plus this, plus the 43 all the way across the bottom. So I have 18 plus 25 plus 43 plus 18 root 2. Excuse me. 18 plus 25 plus 43 is, I believe, 86. And then 18 root 2, nothing happens to. So that is my answer. Finally, number 4. Find the perimeter of quadrilateral QRST. Again, they want the whole figure this time, so that's nice. Not catching me off guard like we did in number 2. And they have this dotted or dashed. So we have Q, R, S. This is not my best polygon ever, but you can look at the one on your page and be comforted by its accuracy. And this is 60 degrees. And this is a right angle. So that means that this triangle QTS is a 30, 60, 90. Okay, so QS is the long leg of a 30, 60, 90. So if we want to find the short leg and we're starting with the long leg, we divide by square root of 3. So 36 root 2, 36 root 2 divided by square root of 3. We can't leave it like that, so we have to multiply by square root of 3 on top and on bottom. On the bottom, that's going to give me just 3. On the top, it gives me 36 root 6, and it's over 3. 36 divided by 3 is 12, so 12 root 6. So that means in this right triangle, the long leg is 36 root 2, the short leg is 12 root 6. Short leg times 2 gives me the hypotenuse, so this is 24 root 6. This triangle over here, QRS, is a little bit easier because it's an isosceles right triangle, or 45, 45, 90. And the hypotenuse has a square root of 2 in it, which if I divide by square root of 2, is just going to cancel out. So QR and RS are both just 36. So now I'm ready to find the perimeter. So I will add 36 plus 36 plus 12 root 6 plus 24 root 6. That's 72 plus 36 root 6, and that's as far as I can take it. Hope this helped. Have a great weekend. See you Monday.